So what happened in an isolated atom, discrete in an isolated atom, discrete energy levels are present. Okay, discrete energy levels are present like discrete energy levels are present like straight lines. Discrete energy levels are present like straight lines. In an isolated atom, discrete energy levels are present like straight lines. So like this kind of thing, like straight lines, discrete energy levels are present like straight lines. Okay, and so these kind of how are these kind of things, you know which theory, according to the Bohr's theory, this kind of thing happens. Okay, now what happens, now the what happens, the interesting thing happens when uh, when crystal is formed. Now when a crystal is formed, when a crystal is formed now when a crystal is formed, okay, huge number of atoms, huge number of atoms comes closer to one another. Huge number of atoms comes closer to one another. So in that case, they are no longer isolated. Okay, so no longer isolated and come close and to one another, and so and the distance between the distance between the atoms and the distance between the atoms becomes, say, 2 angstrom to 3 angstrom. What is this? That is a value, that is the lattice constant. Okay, 2 angstrom to 3 angstrom. So now what happens now? The electrons, the extranuclear electrons, okay, the extranuclear electrons, their behavior little bit changes. Okay, so now the um, outermost outermost electrons have some new interaction. Outermost electrons have some new interactions. Okay, outermost electrons have some new interactions. What are those interactions? Number one is what? Number one is with electrons of the neighboring atoms, with electrons of the neighboring atoms, and number two with nucleus of the neighboring atom, nucleus of the neighboring atoms. Okay, so what happens here? Say this is an isolated atom, this is the nucleus, this is the nucleus, and this is the extranuclear electron. This is the nucleus and this is the extranuclear electron. Okay, now this is an isolated atom. Now what to say, another atom comes closer to this, so this will also have isolated this electron like this. Now what will happen? This electron will start interacting with this much, no? And this will also, there will be interaction with this also. So this kind of two interactions will be there. Okay, this kind of two interactions will be there. That is, these electrons will interact with the electrons of the neighboring atom as also with the nucleus. Okay. So now what happens actually? So now it happens like this kind of thing happens actually. This is one nucleus, this is another nucleus, and this kind of thing. I mean, the resultant is like this. Okay, so what will happen? There will be overlap of atomic orbitals, okay, there will be overlap of atomic orbitals, and electron will be shared by both atoms. Electrons will be shared by both atoms. Okay, so now what will happen actually? Now here I have shown the example of two atoms which have come closer. Now as I have shown you in lattice, what happens in a lattice? These are the suppose planes. Here these atoms. Okay, these are the molecules are here. Okay, so they are very close to each other. Okay, they are very close to each other, like this. So in this case what will happen? So here already see I mean this what I had told here, that so now the outermost electrons have some new interactions. Okay, outermost electrons have some new interactions. So here I mean the orbitals will overlap. Okay, the orbitals will overlap, and this will give rise to, I mean, so in a crystal where there are usually 6.023 into 10 raised to 23 atoms. Okay, in that case what will happen? In that case the huge amount of overlap will occur. Okay, huge amount of overlap will occur, and in that case electrons will have different energy level. In that case electrons will have different energy levels. Okay, in that case electrons will have different will have different or slightly different will have different energy levels. We have slightly different energy levels than that in an isolated atom. That means what will happen? Here see, here there are single energy levels. In that case what will happen? There will be many like here also there will be another energy atom. Here also there will be another. All will overlap, and 13.6 instead of 13.6, this will be 13.6, but more than 13.6 there will be another energy level, say of value 13.55, another of value 13.52, another of value 13.59. Like this there will be many energy levels here. Okay, so you can understand it more clearly now. Now suppose let us consider a sodium atom. Okay, let us consider a crystal of sodium consisting of 1 mole of sodium atoms. Okay, in a crystal of sodium, let us consider a sodium crystal consisting of 1 mole of sodium atom. Okay. So now let us see. I mean, in these cases, you need the electronic configuration. So electronic configuration of sodium's is how much? What is the atomic number of sodium? As I said that day, you have to remember the periodic table. That is hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium. Sodium is 11. So what is the 1s2, 2s2, 2p6, 3s, 6 plus 4, 10, 3s1. Okay, 3s1. So I mean this will be the thing. Now you see very nicely. You see 1s2, 2s2, 2p6. Let me write it here also. 1s2, 2s2, 2p6, 3s1. So how will the energy levels look like? How will the energy levels look like? See, this one will be this 1s shell. This one will be the 1s thing. Okay, this one will be 1s. Then this one will be 2s. Okay, then this one will be 2p. Okay, then this one will be 3s. This one will be 3s. Okay, now what is the thing? For an isolated atom you have got this thing, right? For an isolated atom I mean this is the energy level. For an isolated atom this is the energy level. Now let me draw here. This is the nucleus. This is the nucleus. Okay, and here are the shells. Here this is the K shell. This is this 2 is the L shell, and P is the subshell actually. These two are the subshells. Okay, and then there is the there is the M shell like this. Okay, so this is the thing. Now what happens? Now we have considered how many n number. Let us consider a crystal of sodium consisting of 1 mole of sodium atoms. 1 mole means capital N. 1 mole mane n of sodium atoms mane 6.023 into 10 to the power 23. Okay, now what will happen now? When I mean here another sodium atom will come. Okay, here another sodium atom will come. So again here nearby another sodium atom will come. So in there will be n number of sodium atoms. So what will happen? This 3s will be split into how many? 3s has got I mean 1 electron. So since there are n number of shells, sorry, not shells but n number of atoms here, so there will be like n number of 3s here, isn't it? Since there are here 3s has got 1 electron, right? Now there are n number of atoms here, right? In sodium atom there are n number of sodium, not atom, sodium lattice or sodium crystal. There are n number of sodium atoms are here. N number of sodium atoms. N number of sodium atoms. Okay. So since there are n number of sodiums, so since each sodium atom in the 3s shell they have got 1 atom, so n number of sodium atom, so n number of sodium atom will have what? N number of what? 3s electron. N number of 3s electron. So n number of sodium atom will have n number of 3s electron, isn't it? So what will happen? All will overlap. So like this, all will overlap, and what they will become like this. They will become like this. All these this will produce energy levels like this. So this is this will be around say 1 electron volt. So what will be this? This will be actually almost equal to 10 raised to 6 into 10 raised to 23 energy lines. 23 energy lines very close to each other very close to each other, which appears as a band. There will be like 10 raised to 23 n number, what I এখানে যেটা বললাম আমি যে n number of sodium atom রয়েছে, তাহলে 3s এ ইলেকট্রনও কটা থাকবে টোটাল ক্রিস্টালে? n 3s ইলেকট্রন থাকবে nটা, তাহলে ওটা নিজেদের মধ্যে এরকম ওভারল্যাপ করে এরকম একটা একটা ব্যান্ড তৈরি করে ফেলবে, সবগুলো এরকমভাবে কাছাকাছি, মানে এদের মধ্যে তাহলে এই দুটো ইয়ের মধ্যে গ্যাপ কীরকম হবে? এগুলো তো একদম কাছাকাছি, এই একটা আরও ছোট গ্যাপ হবে। তো হোয়াট উইল বি দ্য গ্যাপ বিটুইন দিস এনার্জি লেভেলস? This is one electron volt, and there will be how many energy levels? 10 raised to 23. So difference between two successive energy levels will be equal to 10 raised to minus 23 electron volt. Difference between two successive will be 10 raised to minus 23 electron volt. Okay, 10 raised to minus 23 electron volt. Definitely, the total gap is 1 electron volt, and divided by n, when it's 6 into 10 raised to 23. I'm ignoring 6 because 10 raised to 23 is much higher than 6. So 1 by 10 raised to 23, that is 10 raised to minus 23, right? So this is the thing. Similarly, 2p will have how many electrons? 2p will have like this 6 electrons. Okay, so there will be 6n, right? Now here the interaction will be little bit less than 3s, because this is the little bit inner shell. 3s is the absolute outermost shell. Okay, here the interaction will be little bit less. Let this be 2p, here 2p. Okay, so the interaction will be that is why the splitting, this is called as the splitting. Okay, will be splitted into this single energy level, will be split into how many energy levels? 10 raised to 23 energy levels. Okay, similarly here also there will be this kind of splitting. Okay, this kind of splitting will be there. Okay, and in 1s will not be disturbed. 1s will not be disturbed because it is nearest to the nucleus, and since 1s is nearest to the nucleus, so it will not be disturbed. There will nothing happen to this 1s thing. Okay, because it is ওটা তো একদম ভেতরে রয়েছে, তাই ওটা অন্য ইয়েদের সঙ্গে কোনো ইন্টারাকশন হবে না। Okay, so this is the thing. Now what will happen here is that similarly here also 2s will also there will be some splitting like this. 2s also there will be some splitting like this kind of thing. Also there will be some splitting. Okay, Achha, now you see here that I mean here actually one thing I missed out is that here in S can accommodate actually how many? S can accommodate how many electrons? S can actually accommodate two electrons. Okay, so the crystal of sodium can accommodate how many actually? If it can, one single isolated atom can accommodate actually two electrons, can accommodate uh, 2n electrons in the কি বলবো in the third shell. The crystal of sodium can accommodate actually 2n electrons in the third shell. Okay, can accommodate means it can accommodate, it has provision. Okay, but here actually what মানে only there is one electron na. Okay, only the one electron is here. So so what will happen here? So 2n electrons in third shell. Now what is happening is that you see here that here is actually one electron. Okay, now but it is not actually completely filled, whereas the first shell is completely filled, second shell completely filled. Okay, that is this the 2s is completely 1s, so there is no interaction. 2s is completely filled. Now here the energy levels are actually much smaller, গ্যাপ ইজ, এখানে যত গ্যাপ ছিল 10⁻23 ইলেকট্রন ভোল্ট, এখানে কিন্তু গ্যাপ আরও অনেক বেশি কম, কারণ বুঝতে পারছো এখানে এইটা 1 ইলেকট্রন ভোল্টের থেকে ডেফিনেটলি অনেক কম, ঠিক আছে? কিন্তু আর এইগুলো সেরকম অনেক নাম্বার অফ লাইন সেই একই 10⁻23 হবে, তাই না? তো ওকে, সো নাও here the diagram is not here. This will actually not be completely filled because there are there are 2n electrons. Only there will be n electrons. That means it will be half filled, right? This will be half filled. So you have to redraw it like this. This will be actually half filled. This will be half filled like this. Then there is 2p. There is 2p, like 2p is completely filled. Okay, then there is the 2s. I'm not drawing it like this here. Then there is 1s. Okay, now as I taught in statistical mechanics, what did I teach you? That what is a valence band? Or rather, what is the Fermi level? Fermi level is that level up to which at 0 Kelvin. Remember, all I am doing at 0 Kelvin. At 0 Kelvin, it is the highest level up to which all the levels are occupied. So this is the valence band. Okay, this is the valence band, that it is occupied. This is the valence band, and which is not occupied, this is the conduction band, which is empty. That is the conduction band. This is the valence band, and this is the conduction band. I hope it is more clear to you after I am teaching this solid state physics, that is about that Fermi level and all those things. That is the highest level up to which all the shells, all the energy levels are filled. Okay, so definitely till here energy levels are filled. 2n electrons, n electrons, and here this is empty. Okay, this is empty. So this is actually the valence band, and this is the conduction band. Okay, in fact everything below it is valence band, and here there is the conduction band. Okay, so this is the thing. Achha, now you will let us take another example. Here it will become more clear to you. Now let us take a crystal. Let us take a crystal. Let us take a crystal of silicon. Okay, definitely containing n atoms. Let us take a crystal of silicon containing n atoms. Okay, now silicon, what is the atomic number of silicon? Z is equal to 14. Okay, Z is equal to 14. So again, write its electronic configuration: 1s2, 2s2, 2p6, 3s2, 3p2. Okay, 3s2, 3p2. Okay, so this is the thing. Now see very carefully. Okay, number of electrons in outer orbit, of each silicon atom, number of electrons in outer orbit of each silicon atom is equal to how much? In outer orbit, number of electrons in outer orbit means this third one, so this is equal to 4. Okay, so total number of electrons. So total number of electrons in outer orbit of silicon crystal will be what? Silicon crystal will be 4n. Okay. There now number of outer energy levels available, that is like this sodium kind of thing. Okay, available মানে what is the accommodation, how much can be, মানে কতটা জায়গা রয়েছে এখানে, number of outer energy levels available in each silicon atom, number of outer energy levels available in each silicon atom will be what? In the outer energy levels, here P is 2, right? So মানে P is how much? Like this, Px, Py, Pz. So how much you can accommodate here 1 2 3 4 5 6, right? And here S, for S there is 2, so this will be 8. Okay, now degeneracy, I was talking about degeneracy in statistical mechanics. Here also is an example of degeneracy, that is this Px, Py, Pz. Okay, Px, Py, Pz, like I mean for this P shell, I mean this shell actually, all these there will be electrons here, all the electrons will have the same energy actually. Okay, all the electrons will have these are the energy states actually, but all these electrons will have the same energy. So this is also an example of degeneracy. So number of outer energy levels in available in each silicon atom will be 8. Okay, so number of outer energy levels available in each silicon crystal will be what? Silicon crystal will be 8n. Okay, in silicon crystal will be 8n. Okay, number of will be 8n. Now out of the available 8n energy levels, out of the available 8n energy levels, 4n are filled. Out of the available 8n, 4n are filled and 4n are empty, definitely at 0 Kelvin, right? Definitely I mean here how many 8 can be accommodated, but there are 4, right? In the outermost shell there are 4, but 8 can be accommodated. So out of available 8n energy levels, 4n are filled and 4 are are empty at 0 Kelvin. Okay, so you can now write it like this, like if you draw a graph like this, this is the x-axis and this is the y-axis. Here you will write the energy of the electrons, energy of the electrons, energy of the electrons. Okay, and here you will write 1 by r. Here you will write 1 by r. Okay, so this one this one will be this I am not thinking about the yeah, I mean below shells. Okay, that is first shell, second shell. I am not thinking because they are completely filled. Okay, they are completely filled and their interaction will be also less. So I am not thinking about those. So let's think about these things. So now this will be what? This will be the like which shell? The 3s shell. That is L is equal to 0 for S. L will be 0. Okay, and this is the what? 3s subshell. 3s subshell. Okay, and this is the energy level for what? For this L is equal to 1, that is P, and what? 3p subshell. 3p subshell. L is equal to 1 and 3p subshell. And this is what? This is the energy level for, again, this is the isolated atom. You see, isolated atom. 1 by r. R is what? R is the distance between the, what to say, distance between the atoms. Okay, R হচ্ছে distance between atoms. R is the distance between atoms. Okay, now you see R is less, right? R is in this case, R is so R is less in this case. Sorry, R is more. Sorry. R is more. That means R is more. That means 1 by R is less. When it's starting from here, R is more. An isolated atom means distance between atoms is very high. So in this case, this is the for isolated atom you think. Okay, so for this isolated atom, 3s will have how many electrons? 3s will have this is the isolated atom. Okay, fine. But when you are what to say, when the atoms are approaching, when the atoms are closing, distance between the atoms is closing down, in that case this 3s subshell will have how many electrons? There will be 2n electrons. 2n electrons will be there because here 3s the isolated atom, a single atom has got 2 electrons. In a 3s subshell it has got 2 electrons, and 3p has got how many? 2n electrons. Okay, 2n electrons. Okay, so again now this how many states will be there? There will be 2n electrons. Okay, but how many states will be here? There will be definitely 2 states because 3s s can be in how many states? This one is upspin, one is downspin. So there will be 2n states. There will be here 2n states. Okay, and here there will be how many states? 6 electrons can be accommodated. So there will be 6n states. Okay, there will be 6n states in this case, 3p shell. Okay, so now what will happen? Now as they will approach each other, what will happen? Again this will be split. Okay, this will be split into your levels. Now I think I have to draw another graph. I cannot draw it here. Okay. Okay, here this is 1 by r. Okay, so this is the energy of the electrons. Energy of the electrons. Okay, and again this is L is equal to 0 3s subshell, and this is L is equal to 1 3p subshell. Okay, so so now here it will again split like this. Okay, it will again split like this. Now this kind of splitting will be there. Okay, and this one will again split. Here I have drawn it little bit below. It will come out, say here it will come out. So this is L is equal to 0. Okay, like this. Okay, so in this way, so here this there will be energy level like this. All the energy they will be splitted like this. So like this, they are splitted like this, as I told it earlier also, and here also these are splitted like this, equal spacing. Equal spacing like this. Achha, now what will happen at this point? What will happen here again? You see that here there are I mean this one is the 3s subshell. Okay, 3s subshell, and this is 3p. Now again you see here 3s is completely filled. 3p is what? 3p is not filled completely. Okay, so I mean 3 in the third shell. There are how many? There are 4n actually, but total accommodation can be 8n. As I wrote here, number of outer energy levels available in silicon crystal is 8n, but 4n are actually filled. Okay, so what will happen here now? This 3p and 3l they have overlapped already. Okay, they have overlapped. Now what will happen is that these electrons, okay, now when they are overlapping, when they are mixing with each other, what will happen? This is the lower energy level, so the electrons will always try to remain in the lower energy level. So everyone will come in the lower energy level. It is a kind of hybridization kind of thing. So there, this will be filled. Okay, this will be filled. This will be filled energy level, and this one will be empty, and this will be the energy gap. This one will be the energy gap, which is called as the Eg, or the this is called as the band gap. This is called as the band gap. This is called as the band gap. Okay, so here there will be and let us take this thing as this thing. Here the crystal formation will take place. This is 1 by r0, or 1 by, say, a is the lattice constant. Okay, here the crystal formation will take place. Crystal formation, here the crystal formation will take place. That is, the distance between the atoms is a. this thing A. Distance between the atoms is A. Okay. So here there will be how many electrons here? There will be how many? Field is what? There will be 4n out of 8n. 4n will be filled. So 4n states and 4n electrons. Okay, 4n states and 4n electrons. And here there will be 4n vacant 4n vacant states. 4n vacant states. Okay, and this gap between the field shell, this will be the valence band. This will be the valence band, and this will be the conduction band. This will be the conduction band. This will be the valence band, and this will be the conduction band. Okay. So in this way, basically a band is formed in solids, and the distance between this is the concept of valence band and conduction band. And depending on this valence band and conduction band, solids are classified into three areas: that metals, semiconductor, and insulator. In metals, what happens? There is no gap. Eg is 0. In metals, Eg is 0. Okay, in semiconductor, there is certain gap is there. This is the conduction band and this is the valence band. Okay, the gap is say from 1 electron volt to 3 electron volt, kind, it varies. And in insulator, the gap is very, very high. Insulator, the gap is very, very high. This is conduction band and this is the valence band. The gap is very, very high. Okay, this gap is very, very high. So this is the how you can classify between metal, semiconductor, and insulator. Okay. So let me tell this little bit shortly again. So here this is L is equal to 0 and this is the 3s subshell and this is the 3p subshell. Now 3s is filled, as you can see, 3s is 2. So okay, so 2n will be here, and total there will be how many? That there will be 2n plus 2n, that is 4. Here there can be 4n. Here there can be 2 plus 2 plus 2, that is, it's 2 plus 2 plus 2, that is 6. 6 plus 2, this is 3s and this is 3p. Okay, 6 plus 2 is 8n. Total there will be 8n. Okay. And now what will happen? This is the isolated atom. This is the isolated atom. See here, I should have written here. I have written here that this is isolated atom. Okay, this is the isolated atom. Now what will happen? The more they come close, the more they come closer, the more they interact, with nearest electrons. Okay, comma, nucleus. The more they interact with nearest electrons and nearest nucleus, and the more splitting happens, you see here that the more splitting happens. You see here, as the distance increases, the splitting. You see here, the splitting here is only this much. As the distance splitting is this much, and here it has been it is this here it is this much. Okay, the more the distance increases, the more splitting happens. Okay, now what happens here? Now at this region, this is called as the crossover point. This is called as the crossover point. Okay, means after this point there is no identity between 3s and 3p. Okay, after the crossover point, there is no identity. After the crossover, there is no identity of 3s and 3p. There is no identity of 3s and 3p. Okay, here what happens? The more splitting happens. That is, more splitting means more overlapping happens. And after this point, what happens? That these electrons, which are in the 3p subshell, they think that their natural tendency will to occupy the more lower energy, so they come to the lower energy. Actually, this kind of hybridization kind of thing happens. So everything comes to lower energy, and this is empty. So here there are 4n vacant states. Here there are 4n filled states. Okay. So after this point, what happens? There is sort of remixing of the atomic orbitals happens. Okay. After the crossover point, there is no identity of and remixing of atomic orbitals. Remixing of atomic orbitals take place. Remixing of atomic orbitals take place. Okay. Producing take place such that all the electrons occupy the lower or 3s energy state. Lower or the 3s energy state. Okay. So this thing. So this lecture ends now. Okay. In the next lecture I'll give a definition of valence band and conduction band and proceed to the next topic.